To continue our tour of the solar system, let's talk about asteroids. Now, asteroids are really interesting. First of all, they're sort of, they're rocky chunks, and some of them are, very oddly shaped like this right here. So these are rocky chunks. There's many found in what we call the asteroid belt. So many found in the asteroid belt. And that's an area between Mars and Jupiter. So somewhere between Mars and Jupiter are found a lot of these asteroids. Now what's neat is that many of the asteroids, they actually have moons around them. So they can have moons as well. Again, the question is, what do you call a moon, or do you call it a satellite? But some of these ones actually have things sort of orbiting them, which is kind of neat. And some of these things, if they're bigger, they can actually be more circular, because we think that they have enough mass to have enough gravity to sort of equal out all the stuff. So if they're really rocky like this right here, and you can see that these ones, this one for example, seems to have been hit by a lot of things. In fact, asteroids pretty much always have this. They have lots of these impact craters. So that tells us that the solar system is a very volatile place. Now you might wonder, why is it then that we don't see so many of these craters on Earth? Well, that's because our atmosphere helps to erode things. So on Earth we have a lot of erosion, and so because of that, a lot of these craters get sort of smoothed out. So on Earth, even though we think we've been hit by just as many of these craters, just as many of these things at least, so we should have just as many craters as other objects, we think that because we have an atmosphere, it's sort of helped to smooth it out. But see, on these other objects here that don't have atmospheres, we can see lots of impacts. Now, a lot of these asteroids are actually thought to be leftovers from when the solar system was formed. So, in other words, when the sun sort of condensed, when the sun was actually sort of starting to fuse, and we had all these rocky chunks sort of coalescing together, some of them never made it to planets, some of them just stayed as rocky chunks, and some of them actually were massive enough and ran into each other to sort of make planets, and of course their moons. But asteroids are these sort of chunky things that are going around the sun. Now, of course, after that, we also have things called comets. So comets are actually pretty interesting. They're mainly ice and dust. So they have sort of a core right here. So this is ice and dust. Some have very eccentric orbits. So remember, we talked about eccentricity. That means they have very elliptical orbits. In other words, they're not very circular at all. So something like, if this here is the sun, maybe these comets do something like way out before they come back. There's some famous comets. There's one called Halley's Comet, or Halley's Comet, depending on how you call it. I think it has an orbital period of 76 years. Now, the thing with comets is kind of neat is that, of course, when they come near the sun, because there's lots of ice and dust, well, the ice, when it's near the sun can actually help melt the ice. Because of that and some other reasons, comets actually sort of glow or give off this cool tail. In fact, comets have two tails, but that's a whole other thing. But comets will actually have a tail when they come near the sun. Now, when they're over here, when they're far away from the sun, they still exist. There's still this chunk here of ice and dust. But the problem is, because it's so far away, it doesn't really glow. So that means they're very hard to detect. So we tend to only see comets when they come near the sun and they start sort of glowing and giving off this nice sort of light. And of course then, they tend to do something like, maybe they'll be like this, and over here it'll sort of stick out like this, and it'll stick out like this, it'll stick out like this, because the sun sort of sends the radiation this way. So we see this tail sort of move around as they go around. And of course, as it's far away, it has no tail. So it's sort of, it's there. Maybe over here, maybe it starts to have a little tail. Maybe over here, the tail is sort of longer. Maybe over here, it's even more pronounced. Here it's really pretty to look at. Maybe that's actually what we're seeing here. This is a comet that came nearby. So that's really interesting about comets, at least. They have very eccentric orbits. Now, some people actually talk about, well, how did the solar system form, or what happened with the solar system? This is at least a nice little sort of schematic. It's not really to scale here, but it just shows sort of in order what there is in our solar system. So we have the sun in the middle. Now, of course, this picture would have been taken with some sort of filter, because, of course, it doesn't look like this to our eyes. But if you have a filter for the sun, then it might look like this. And of course, closest to it is Mercury, and then Venus. Now remember, the distances aren't really to scale here. But then comes Venus, then Earth with its little moon called the moon, sorry. But of course, Mars has its own moons. It's got Phobos and Deimos, for example. And it turns out the Russians had a really cool plan this year, or at least this past year, to send a satellite, so to send something from the Earth to Phobos and actually pick up some of the dirt there and then actually bring it back to Earth. It was such a cool mission called Phobos Grunt mission. But the problem was, well, when it went into orbit around the Earth before it was supposed to try to get to Mars, it didn't work, so it actually crashed back into the Earth. So that's too bad. It would have been really cool for it to make it, I think, but oh well. After Mars, of course, is this asteroid belt where all these asteroids are found. And after that comes Jupiter, and it's got lots of its own moons. We've got Saturn with lots of moons, and then Uranus and Neptune. And then we have these comets that come around and do these, weird eccentric orbits like this. So I think that's actually something pretty interesting about our own solar system, is how these things here actually seem to work. Now, what's kind of neat, though, is that we think that when the sun was first formed, of course, that came from hydrogen gases all coming together, and then that got hot enough and dense enough in order to fuse hydrogen into helium. But of course, while it was doing that, there was lots of other material around. And we think that other material sort of coalesced slowly into bigger and bigger chunks, which then ran into each other, which then made these planets. But there was this heavy bombardment. There's evidence that shows that these at least these rocky planets here were hit really, really hard billions of years ago. They're completely pummeled by these large chunks here. So lots of chunks are sort of running into each other. So we call that the late heavy bombardment. And we think that made the Earth so hot, it would have been sort of molten on the surface. Now the question is if it was so molten like that, how can we possibly have liquid water on Earth? And one of the proposed ideas is that the liquid water on Earth actually came from these comets. So these comets, which were past what we call this, sort of snow line, this line where any water is found as a solid ice past a certain distance, whereas closer than that, water found, that's floating around is going to be in liquid form or just evaporate away. But it turns out, that we think that these things which were inside the snow line, in other words, inside here, water would have been in a gas form, and we wouldn't have had liquid water here, which means when Earth formed, we don't think it had any liquid water on it. We think it was all sort of molten hot lava. But then we think that what happened is afterwards, when these comets, for example, came in and pummeled the Earth, we think that a lot of those comets, which contained lots of water, because of course there's lots of ice on there, we think that that's maybe how the Earth actually got all of its water. At least that's one of the ideas behind it. Of course, it's a controversial idea, and then some people even think, well, then did the seeds for life on Earth also come from comets? So there's all these sort of tie-ins with comets and with how life started on Earth. And we think that, for example, in order to have life on Earth, we need liquid water. And it turns out that just about all the life that we see on Earth is sort of liquid water based in some way. So we think that if we're going to look for life on other planets, we need to be looking for places with liquid water. And if that's the case, then, it looks like Mars had liquid water on it at some time. And there's strong evidence to show that it had some liquid water. Whether it was oceans or lakes or things like that, I think it's a little bit more difficult to tell for sure. But there's certainly evidence that Mars had lots of liquid water on it, which means, if you need liquid water to have life, then maybe Mars had life on it in the past. That's why it would be really interesting if some of these Mars rovers would actually detect even fossils. Would be really exciting, because that would tell us then that, first of all, we're likely not alone on Earth. Because see, if life could exist on Mars as well as Earth, then maybe it could exist in other places. Right, so that's part of the interesting part of it. And of course, then we actually look at, well, are some of the other ingredients on comets, found, with life? It turns out that comets contain some amino acids, which are things that we actually find with life on Earth. Now, that doesn't necessarily mean that those amino acids mean life, because of course we can find those amino acids in lots of other cases too. But it turns out there's a really cool mission that's on its way now to a comet, and it's actually the European Space Agency has it. It's called Rosetta, and it's actually going to sort of hook itself onto a comet. So it's going to sort of latch onto it and take lots of samples and take a look at what is on the comet. So that one, I think it's supposed to reach this comet in 2014, I think, if I remember correctly. But in any case, so there's a little satellite that's on its way to meet up with a comet in order to see, does that have the ingredients for life? Because maybe that helps us to understand maybe how life got on Earth. How interesting, I think, at least. So at least this is sort of a quick intro to our own solar system. And of course, we can go a little bit further. We can do something with NASA, actually. The NASA has a really cool webpage called eyes.nasa.gov. And if we do this, it may really slow down my recording, so bear with me if it slows down. But if it doesn't slow down too much, then we can do this cool little program here that lets us tour the solar system. So here, if we do it right, we can actually take a look at our own solar system. Here we go. So I can sort of rotate around and zoom in and out, and that shows, of course, a lot of the other missions as well. So we have the sun in the middle, and you can see some of the different missions being sent out. So there's one called Dawn, and there's New Horizons on its way. This is Rosetta. That's the one that's chasing a comet. It's on its way. But if we sort of zoom in here, we can see another one here. Let's see. We've got, well, if we keep zooming in, maybe we can go and take a look at the sun here. Maybe we can focus on the sun. So if we do that, of course, we can see the sun, and there's sunspots and things like that. And we can zoom out a little bit then and maybe rotate the screen a little bit. So that way we can actually sort of see what happens here. So as we rotate around, we can sort of see that, okay, well, the next thing is Mercury. So if we go and zoom in on Mercury, maybe we can do that here. Let's go see if we can see Mercury. I think it shows us where Messenger is. Yeah. So if this right here is Mercury, it actually shows us where the orbit of this little satellite that's currently going around Mercury. It's called Messenger, and it's taking lots and lots of pictures. So as I rotate around, you can see this is what Mercury looks like. And next, of course, is Venus. So we can go there. So whew, as we fly there, I think it has to load the surface a little bit. Venus is not quite as exciting at the moment, at least. There's not many things orbiting around it. Of course, we have Earth. We're going to skip that and maybe go to Mars. So if we go to Mars, there's lots of exciting things going on there now at the moment. There's a Mars Reconnaissance orbiter currently going around. There's also Mars Odyssey. And if we look at this one right here where I'm zooming in, this is the landing site for Mars Curiosity rover, or the Mars Science Laboratory. Whoops, so I seem to have messed it up here when I'm rotating. But anyway, this right here is where this newest lander has actually landed on the surface of Mars, in a big crater called the Gale crater. And of course, then we can see some of Mars's moons. If we zoom out a little bit, we can see that Mars has Phobos, and it also has Deimos. So this Russian mission, that one was supposed to actually go land on Phobos, which is a really weird shaped little thing here. It was going to go land there and take some readings, which I think is really cool. And after Mars, of course, comes Jupiter, so we can go there. And as we fly to Jupiter, we can take a look there. Well, there's Jupiter as you rotate around. Of course, this is taken with combinations of pictures here. So they've taken lots of different pictures of Jupiter and sort of put them together on this cool program. But if we look at this, as we sort of zoom out of Jupiter, we can see some of its main moons. The brightest ones you can see, I mean, I have a little telescope at home, and with my telescope, I can see Jupiter, and I can see 4 dots. I can see this Europa, Io, Ganymede, and Callisto. Now, Jupiter has a lot more moons than that, but these are the main ones you can at least see easily from Earth. And what's really cool about it is if you wait a little while, you'll see these positions of these ones change. So that really helps you to know that, yes, moons also orbit around things. Then, of course, we have Saturn. We can go there. As you go to Saturn, we can take a look at this one. Oops, there we go. This is a very complex system, and this might really screw up the computer. But it's got lots and lots of moons, tons of them. And in fact, as we see here, can we see? Yeah, there's Cassini. There's the mission here that's actually, this is a satellite that's going around, taking lots of pictures of these different things. So there's lots of these different moons going around. There's Titan. Of course, there's other ones as well. So Saturn has lots and lots and lots of moons. And of course, after we go a little bit further, we can go to Uranus. Ha ha ha. As we go there, we can take a look and see that this one even has some moons as well. It's got moons like, if I zoom out here, we can see there's Miranda and Ariel and Umbriel. And of course, there's other ones like Titania and Oberon. And then, of course, we can keep going and see Neptune and things like that. But we don't have so many pictures of Uranus and Neptune because they're farther out. And, of course, we don't have so many pictures of asteroids, although we have detected some big ones. There are some very, very large ones. In fact, some of them already have their own things orbiting them. So that's actually really interesting. And okay, so that's just a nice little way to tour around the solar system, I think. So of course we can take a look and sort of zoom way out if we go back to the sun, for example. And I think it's a pretty fun little system, a little fun little program to play around with. So that's eyes.nasa.gov. I think it's pretty fun. You can actually see all sorts of things. One of my favorite ones, I think, is if I zoom out enough to see Earth. There it is. Look carefully here at what's happening. There's this thing, well, there's Earth, and there's lots of things orbiting the Earth, of course. But what's cool is that there's a telescope called Kepler, and that was launched from Earth, and that one's actually being used to try to detect planets around other stars. And that's really cool. I'm going to do some videos about how that works. But it turns out that Kepler is not in an Earth orbiting. See, it's not orbiting the Earth. Kepler is actually orbiting the Sun. In other words, it follows the Earth. And there's another telescope, that one's called Spitzer as well, and it's doing a similar thing. Now we've got lots of other things. If we zoom way out, we can see some of the farther things that have actually been sent out. So there's things like the Voyager probes. Those are actually on their way sort of out of our solar system. They were sent out a long, long time ago, and they're just basically on their way out. So these are really, really far away. If we click on Voyager, we can see that it's really, really far away. I don't know if it tells us that, how far away it is, but it's extremely far away. So this one here is one of these that's actually on its way out of our solar system, which I think is really cool. So that was one that was sent out, in the 70s. It was sort of touring around, and it's still sending some signals, at least some of these Voyager ones. There's Voyager 1, and there's another one called Voyager 2, and there's the Pioneer ones. But I invite you to go ahead and go to this NASA site and actually play around with it. It's actually pretty fun. You can sort of zoom around, and they even have some little animations. Like I was looking at one animation that they did where you can actually see or actually play around with the Curiosity rover. In other words, where that one landed. So they have a little animation that shows you all sorts of things about the landing, and so it actually shows you sort of according to the time, and shows you what happened. I think it's really, really cool. I'll see if I can just get that one quickly loaded. I'm not going to show you the whole thing, but just to show you a little bit what it looks like. So hopefully it's loading here. So this one here is an animation to show you what happened with this lander just recently, at least when I recorded this. Of course, we can speed up the time a lot and sort of see what happened as it sort of came in. And of course, then it emitted something. I'm just speeding up the time here a lot, saying, okay, well then it kicked off some different things. Because its altitude then started entering the atmosphere. And then actually what's really cool is you can actually, while it's flying around, you can actually sort of zoom around and change the angle, and you can sort of watch what it was seeing. I think it's really, really interesting, at least. So you can sort of zoom around and actually see how it is that it landed. I think it's really, really interesting, at least. Take a look at sort of what that might have looked like. Oops, it seems I have it upside down all the time. But sort of it landed like this. So here it had this cool lander. It actually used what's called a sky crane, which is an insane sounding method. So what it actually did is it let this little thing down like this here with a rope, so to speak, like a little cable. It set it down, and after that it cut the cables and it flew away. It's really crazy. So after that, what it actually did, maybe we can see it here at some point, it's going to sort of let it down, and after that it's going to sort of take off itself. So this thing right here sort of zoomed away and took off. So there it sort of did what's called a flyaway. I think it's about to do it. So there it goes, it flies away, and it goes off into the sunset. Well, not quite the sunset, it actually flew away a little bit further and then landed. So that's one of the, well, that's the newest one, at least at the time that I make this video. So you can see actually it just sort of flew and then landed far away because they hoped it wouldn't sort of land on this one. And now this one right here, which is, the size of a person, is now roving around on the surface of Mars. So this one right here is just sort of booting around now. It started taking lots of pictures. So this is a pretty cool website, I think. But I think it helps us, though, just to see a tour of our solar system and sort of see what there is around us. So it's a very interesting place, I think. And in fact, I just wanted you to sort of see that around our solar system, it's not just memorizing a few planets here. There's actually a lot of really interesting things about all of them.